Okay, I'd like to recall the theorem on inverse functions. So if this is from a while ago, but if f and g are inverse functions, then when you compose the two functions in either order, you just get back the input. So f of g of x equals x, and g of f of x also just simplifies to x. So it doesn't matter how complicated these two functions are, if they're inverses of each other, they have to be inverses of each other. Then when you compose f of g of x, then you just get back x, right? So also, when we first introduced logarithms, logarithms were designed to be inverses of exponential functions. So that is f of x equals a to the x and g of x equals log base a of x. These are inverse functions. So wait, if these are inverse functions, and we have this theorem about inverse functions of what happens when you compose them, let's apply that. We actually then get new facts, or if you want to call them this, you can call them new formulas. And they look like this. A to the log base a of x just simplifies to x. Log base a of a to the x simplifies to x. If you want to say it this way, that a to the x, a to the whatever, or the exponent doing thing, and then the logarithm, well, because they're inverses, they undo each other. So a to the log base a of x equals x, and log base a of a to the x is equal to x. So let's apply these two new formulas here. First, we'll start easy. Okay, so log base 2 of 2 to the m. Well, that looks like the left side of the second formula. And so that is all just going to simplify to just a plain old m. Right, so a is 2, m is what we plug in for x, and we just get m. Just simplifies to m. That's nice, but that was too nice. Let's try a harder problem. So what about log base 2 of 8 to the m? Now this formula doesn't apply, at least not directly, because you see there's an a there and an a there. We have a 2 here, and oh drats, we have an 8 here. So what do is we can replace the 8 with 2 to the third. So the original expression becomes log base 2 of 2 to the third quantity to the m, and then we can't actually apply the formula quite yet. It just doesn't look right. Let's apply an exponent rule. 2 to the 3 to the m is 2 to the 3m. Yeah, so using a rule of exponents, the part in parentheses becomes 2 to the 3m. So now we have log base 2 of 2 to the 3m. Now it looks like this. A is 2, x is 3m, and so we end up with 3m. Right there. And I want to be very careful and very literal about using these formulas, and also to not take any shortcuts, at least right away. We better understand what we're really doing, make sure we understand step by step. So going from here to here, it used an exponent rule. Okay, what about simplifying 3 to the power log base 3 of h? Well, that looks like this. And so 3 is a, x is h, and we just get h. Well, that one was too easy. So let's take a look at something a little more challenging. Log base 3 of 3 to the power log base 3 of 8y. Well, really same deal. Okay, the 3 is the a, x is 8y, and so we just end up with 8y. That one's maybe too easy. So let's look at something a little more challenging. What about 81 to the power log base 3 of h? Now we can't use this formula directly because this formula here needs an a there and an a there, but we have an 81 and we have a 3. Ooh, those numbers don't match. But we can rewrite 81 as 3 to the 4th. So we have 3 to the 4th quantity to the power log base 3 of h. We still cannot use the formula yet. I get that there's a 3 here and there's that 3 there, but there's also this 4, well, there's this still is just, it's not in the format, but here's the thing. Let's apply a rule of exponents. When you have base raised to an exponent, you get to multiply the exponents. And that here just effectively looks like dropping the parentheses is all it looks like, but really what's happening is it's 3 to the following power, where the power itself is a product. It's 4 times log base 3 of h. We still can't use this formula here. Why not? Because take a look, this stinking 4 is in the way. There's this 4 in front of the logarithm. Can't do anything because of this 4 in front of the logarithm. Except, well, again, we're not going to use this, but recall that we had that third law of logarithms. So we can rewrite this as 3 to the power log base 3 of h to the 4th. So it's this 4 times log base 3 of h that became log base 3 of h to the 4th using the third law of logarithms. And now we have something that fits this format. A is 3, x is h to the 4th. So this simplifies to h to the 4th. That was a more challenging question, wasn't it? Okay, so just to clarify, what happened here was that 3 to the 4 times log base 3 of h became 3 to the log base 3 of h to the 4th using the third logarithms on the exponent. So we just really we zoomed in on part of the expression. It was really the 4 log base 3 of h part that became log base 3 of h to the 4th. Okay, let's simplify log base 2 of 16. Well, using the techniques we're looking at as a first answer, 16 can be rewritten as 2 to the 4th, and now it looks like this, so we can say that we get 4. So this is using the new formula. Now that's actually a lot of work. It worked out. It wasn't, I guess, too much work, but I also want to remind you, log base 2 of 16 is also just good old plain old equal to 4, just by answering the following question. The question being 2 to the what equals 16. So don't forget that. You compare the two ways of doing this, the second answer is just slightly shorter. It didn't use the new formula. So I don't want people one-tracked into just using these. Sometimes people's eyes are looking at the new formulas and going, ooh, shiny. But remember, we had a way to do this before. And in fact, the second answer here, there's something to really appreciate about it because it relies on the original definition of logarithm. Remember how this log base 2 of 16 equals 4? It's here, right? The 2 is the y in this brownish color. 16 is the a here in blue. And then if we don't have this number 4 yet, because you don't know what n is, because it's a mystery, look, it's 2 to the mystery. Yellow is the mystery here. 2 to the something is equal to 16. Okay, let's do another one. Simplify log base 3 of 9 to the 5z power. Well, turn that 9 into 3 to the second. So you have log base 3 of quantity 3 to the second to the 5z. Apply the exponent rule that allows you to multiply the exponents. 2 times 5z will simplify to 10z. And now we can apply our newer formula and get just 10z for this. Let's take a look at 16 to the power log base 4 of 3y plus 1. Turn that 16 into 4 to the second. Now apply a rule of exponents to have 4 to the power 2 times log base 4 of 3y plus 1. Now apply the third law of logarithms to have 4 to the power log base 4 of quantity 3y plus 1 to the second power. And then apply our new formula to get 3y plus 1 quantity squared. Now at this point, let's not try to distribute the square. Not when you have a plus sign here. You can't do that. Don't make up things now after all the other good work. This is really 3y plus 1 times 3y plus 1. So when you expand that all out, you'll get 9y squared plus 3y plus 3y plus 1. And that 3y plus 3y can be collected together as a 6y. For your interactive question, I want you to simplify log base 2 of 1/8.